Creative processes typically begin with generating and exploring multiple ideas rather than refining a single one. Without first exploring diverse ideas, one can converge to a suboptimal idea and spend time iterating it without considering other options. This is known as fixation, a phenomenon that hinders creative processes. In addition to avoiding fixation, another key to success in creative processes is being able to think about the space of possible ideas, referred to as design space thinking. Today, large language models offer an unprecedented opportunity to provide support to these needs. Specifically, the capacity to instantly produce tens to hundreds of outputs empowers them to address fixation by offering users a set of ideas different from the current set of ideas, and generate diverse ideas to reveal the design space to users. However, current user interaction paradigms for large language models do not fully harness this potential. Take users interacting with ChatGPT as an example. When exploring ideas, users engage in prompt engineering, regenerating a new response using the same prompt, or iteratively changing the prompt until the output aligns with the user's intent or their evolving creative needs. We call this approach a single output approach, where users receive one response for one prompt and they refine the ideas during their iterative prompting process. Another interaction paradigm is a multi-output approach, where large language models generate multiple responses from a single prompt. This was explored in recent research focusing on text-to-image generation tasks. Both of these approaches, however, lead users to converge to an initial idea rather than diverge. And as a result, they are not conducive to design space thinking, which is critical in creative processes. So how can we leverage large language models to address fixation and encourage design space thinking in creative processes? We propose structured multi-output approach. In this approach, when users prompt, we first derive dimensions relevant to a topic or task from prompt. Then, we generate responses that contain values of these dimensions to enable users to explore the design space in a structured manner. By leveraging dimensions, we can support structured generation and exploration of design space. To explore the feasibility and usefulness of this approach, we developed Luminate, an interactive system that shows how large language models can be used to power design space thinking and human-AI co-creation. To showcase the workflow and its features, we present a user scenario. Chris is a professional writer who writes children's books, and he decides to use Luminate for his next book. Without any specific idea on what he wants to write about, he first recalls recent events for inspiration. And he remembers running into a rabbit outside his house in the morning. So he decides to ask AI to generate stories involving a rabbit. Luminate instantly generates dimensions important to writing a story and generates 40 story ideas reflecting the values of these dimensions. He clicks on each dot to quickly check a few stories displayed in the text editor. As he zooms in further, he sees the title of the stories, which allows him to get a quick overview of the generated stories, and the semantic zoom reveals more details about the stories as he zooms in further. And he bookmarks the story so he can revisit it later. Then he zooms out and uses dimensions and their values to engage in the structured exploration of the design space. By looking at the dimensions and their values, Chris begins to develop a comprehensive view and understanding of the space of possible story ideas. Now that Chris has some understanding of the design space, he decides to dive in and explore specific stories. And he finds labels underwater and adventure interesting, so he selects them to quickly find the story containing those values, bookmarks it. But then, since there's only one story, he asks Luminate to generate more stories that also contain those values. Luminate instantly generates those stories. After exploring the design space, Chris finds the story saved bookmarked. And after selecting the story he wants to include in the writing, he edits the text to embed it into the editor. And he continues to explore by generating similar stories. He also uses the search feature to quickly check whether any of the generated stories has the word ocean. And using this feature, he is able to find it immediately. Additionally, Luminate allows users to add user-defined dimensions, further amplifying the types of responses users can generate. Our study with professional writers who use Luminate for various creative writing tasks revealed that our approach helps them avoid fixation and develop understanding of the design space. Overall, our work makes unique contributions, including a framework for enabling structured generation and exploration of design space with large language models, and Luminate, a system that demonstrates this approach.